Hello everyone, welcome back to my channel Leela Web Dev. Today we are going to dive deep into the streams in the Node.js, and also we are learning about the different types of streams. So we know about this. Streams are an essential part of the Node.js for handling large amounts of data efficiently. So now what we need to do, we will cover different types of streams, how they work, and their real world applications also. Make sure to watch till the end to understand how to use the streams properly and avoid the memory issues. Let's try to see it. So before coding, I am trying to explain you in detail about this one. So why? Because in the coding you will be able to not understand clearly. So that's why I am going to theoretical part first. So what are streams actually? So let's try to have an overview about this one. Streams allow us to process data piece by piece rather than loading everything into a memory. So this is the main thing. They are useful when working with large files, network requests, or any continuous data flow. Streams are built into Node.js and provide a powerful way to handle the data. So this is all about the thing. And now you need to understand the different types of streams that are available in the Node.js. Let's paste it here, the code. The types of streams in Node.js. There are typically 4 types of streams in Node.js. The first one is the Readable Streams, which is used to read the data. Example, reading a file or receiving a request. Next one is Writable Streams, used to write data. Example, writing to a file or sending a response. And the last one is the Duplex Stream. Third one is the Duplex Stream, both readable and writable. Example, sockets. Transform Streams, a special type of Duplex Stream that modifies the data as it is written or read. Example, compression or encryption. So these are the 4 different types of streams that are available in the Node.js. First of all, let's try to understand about the readable stream and also the writable stream. So understanding readable and writable stream. Let's consider an example. You have a huge file that is about 10 GB and you want to read it and write it to another file. A readable stream will read from the file in chunks instead of loading the whole file into the memory. A writable stream will write to another file efficiently. This prevents excessive memory usage and improves performance. Another example is handling HTTP requests. Reading from a client's request is done via readable stream. Writing the response back is done via writable stream. Efficient streaming allows handling multiple requests without overwhelming the system. So this is the main thing. And let's try to understand about the duplex stream and also transform streams. Duplex stream and transform streams. Duplex stream are both readable and writable. Example, a network socket where you can send and receive data at the same time. Transform streams modify data while reading and writing. Example, as I have told you, encryption and compression. When encrypting data, you transform it before writing. When compressing data, patterns are detected and stored efficiently to reduce the size. These modifications are done using the transform streams. So let's try to understand how the streams actually will have it. Okay, so let's try to see this one. So internal buffer and high watermark. What is these two things? Let's say that each stream has an internal buffer that temporarily holds the data. The default size for each stream is 16 KB, that is around 16,384 bytes. This is called as a high watermark, controlled by a high watermark. When the buffer fills up, the data is processed in chunks. This improves efficiency because fewer write operations are needed. So that is the main thing. So memory issues and draining mechanism. Let's try to understand this one also. If you write faster than the buffer empties, excessive data is buffered in memory. If too much data is buffered, memory usage increases and performance drops. To prevent this, use the drain event to wait for the buffer to empty before writing more data. This ensures controlled memory usage. For example, let's say that if we write a huge file, example 800 MB at once, memory usage will spike. Instead, we should write in chunks and wait for the buffer to drain. So we have a different types of events and properties and methods for that one. So here we wait for the drain before we writing more data. This avoids excessive memory usage. So that means what I was trying to tell you is, for example, let's say that here let's say that this is a readable stream, okay, or otherwise let's say the writable stream, okay. writable stream. So this is a writable stream. Okay, now let's try to write it here. This is a writable stream. Okay, let's try to make it bigger. Okay, so this one is not making. Okay, leave it. So now this is a writable stream, and here in this writable stream what you will have it is, inside this one you will have a, so you, oh sorry, no, not like this, color picker, pencil, brush. So you will have a, here I can do in such a way that this is an internal buffer. So this one is around 16 KB, which we have discussed. So in the writable stream we'll have 16 KB, and this writable stream, this entire writable stream, so you will have the events, properties, and also the methods inside this one. So you will be having 3 in the writable stream. So for example, whenever you are getting a data as a stream here, so here you will write the data into this internal buffer using stream.write, which we have seen in our code. And when this buffer is filled, 16 KB of data is filled, means then this one will be written to another file. Okay, and this buffer will be emptied. Again another stream of data will come into this one. So in the same scenario you will be having a readable stream also. Readable stream also, a stream of data, you will be getting it from the network card or something like that, and you will read it here, something like this, and you can do some process data or something like that. So this is how actually the readable stream or readable stream you will be having. So when you see this duplex stream, okay, so it will have both readable stream and also a writable stream. So this one will have only one buffer, and this one will have 2 buffers. So that is the main concept which I want to explain you. So in conclusion, what I want to say is, streams are powerful and efficient for handling large data in Node.js. Readable, writable, duplex and transform streams have specific use cases. Buffering and drain events prevent memory issues. Using streams correctly optimizes the performance and reduces the resource usage. So that's it guys about the streams concept. So I will try to explain you in the code in the next scenario onwards. You will try to see this entire streams concept in the code so that you can able to understand it clearly. So I hope you found this explanation and all those things helpful. If you like this video, please like, share and subscribe. Let me know in the comments if you have any questions. See you in the next video. In the next video, what we will try to do it is, we will see the practical implementation of the streams. What we have did it right. In the previous video, we have written the file using the streams. In the next video, we will try to see how we can handle this memory usage, how we can decrease the memory usage and all those things. We'll try to see. Thank you.